Hello guys, how's it doing? I hope you guys are doing well. So today we're gonna talk about Cisco ISE. This video was supposed to be posted on Wednesday, but I have a couple of issues, and let's talk about this guy today. So basically, I'll give you a short introduction about ISE, what it is, how we can use it, the features, some of the features, and then we go to the hands-on lab just to show you guys some informations and some configurations that we can do on ISE. So what is ISE? So ISE is a network access control and policy enforcement platform. So it uses the AAA model or the AAA research to identify who, when, what, where, how, to identify which the policy enforcement platform, the threats. It also has some integrations to get some common vulnerability scoring system and apply rules or apply policies based on this information. So as you guys can see on this presentation, ISE provides to us visibility, control, and compliance for wired connections, wireless connections, and also VPN. ISE also has the power or the feature of communicating with APIs with a lot of partner ecosystem using PXGrid or APIs, and we can do a role-based as control, we can do guest access, we can do bring your own device, we can secure access, we can check for if the device is compliant or not, like okay, this compliance is running my antivirus, is running my last patch update, is running these things, and we'll do labs for all of these technologies, and I will show to you guys more things about it. So ISE is divided in personas. So as you guys can see here, let me get my note here. So as you guys can see here, the policy service node is responsible to make policy decisions, and also is where we configure the radios and TACACS. They are the radios in the TACACS server. So the PSN is where we configure. For example, we're gonna configure our switch, our wireless controller, or our firewall will be the IP address of the PSN. So the PAN, policy administration node, this one, it's a single panel of glass for ISE. So everything that you're gonna configure on ISE, everything that you're gonna check the logs, everything it's gonna made by here in the PAN. And also you configure everything here, and the PAN replicates that to all of the nodes. The monitor node is responsible for reporting and logging nodes, and also is the syslog connector for all ISE nodes. And same thing, right? I want to check logs, I go to the PAN, I will not go to the monitor. And PXGrid, it's sharing context information with Cisco devices and also with other vendors, because PXGrid is a IEEE technology. So we can share, for example, information with Checkpoint, with some of their devices that support the PXGrid. So I will talk about now about the deployments. Oh, and as you guys can see here, there is one thing so that I will explain later when we talk about deployment. In a standalone ISE, for example, I just have one node, I can have all of these services enabled in one node. But in a multi-node design, I can have one node just PSN, one node just PAN, and one node just monitor, and one node just PXGrid controller. So we will see that now. So for example, this is a small deployment, right? So we have only two ISE nodes, and these two ISE nodes has the three personas, so PSN, PAN, and monitoring. And secondary same thing, and on the network access device, on the routers, switches, firewalls, wireless LAN controllers. We have one as primary and one as secondary, because if this one goes down for any reason, this one will take over all of the authentications. And I will give you more details when you're gonna configure that here. But basically, if you access the PAN, or if you access this primary host and the role is primary, you will configure everything here. But if you try to access this, the secondary one, the dashboard is very limited. You can do anything. Basically, you can just check some NTP. You can also check a little bit about the deployment and certificates. So we always will go to the primary PAN to do configurations, to check logs, no matter what's happened. All the other nodes, the dashboard will be limited, and I will show to you guys that later. So this is a small deployment. Like there is some numbers that Cisco provides. I will not go through it because the focus here is put the hands on the lab and show to you guys the ISE. But this is a small deployment, right? So we have two nodes, the two nodes with the three personas. We can also add the PX grid here and PX grid here if you are using a small deployment. So let's go to a medium ISE deployment, which will of course depends of the size of your network, how many devices, how many sites you have, how many authentications you needed. So in this case, we have DCA and DCB, right? And we have one box, one node with as PAN and monitor primary. The other one in the DCB, same thing but secondary. We have two PSNs for this DC. So one PSN here, another here, one DCA, DCB, and we'll talk about that later. But we have a dedicated Active Directory for these PSNs. So this Active Directory works as identity source. It's for this one, and this is a recommendation from Cisco. So basically, if you have distributed deployment, you should have an AD close to the PSNs, because that's why, for example, we have site A, site B, and site C here connected to our DC, and on this PSN we have this Active Directory close to it. This one, this access switch is using this one, so don't need one closed, but these two again need one Active Directory closed to avoid delay during the authentication, and we'll show to you guys that later. And we have like large deployment where we have, for example, basically there is two differences here. First, I have one node dedicated only for PAN, one node dedicated only for monitor, and then we have primary and secondary. And usually these monitor nodes, because of the size of the deployment, they have more capability, like more vCPUs, or if it is appliances, 3695 is the biggest one box with more powerful, more processors, more memory in this thing, and use the PAN only to administrate. And we can use for example, we have the two PSNs here, same thing, but we can use load balancers here, for example, to load balance this. For example, this switch has this one as primary, and if this one goes down for any reason, it will go through here. So we are not using the direct IP of the PSN, we are using the IP address of the load balancer. I already worked with a deployment like this. It works pretty well if you follow the guide from Cisco, like having the Active Directory here, respect the timeout, the latency that should be 300 milliseconds between these devices. So if everything is following the rules, it works pretty well. There's no big issue. The synchronization always happen from the PAN to the PSNs. Monitor is speaking very well. So this is about the deployment, how we can deploy ISE. But let's talk a little bit more about ISE itself. So as I said, we consider every endpoint with users, devices, IoT, connecting to the network using the network devices using switches, WC, AP, VPN gateways like firewall, ASA, or FTD. So every time that these guys try to connect to the network using these guys here, so here the names, but there is another name for that. So we used to call this supplicants, because they will supply the information. The network device will be the authenticator will enforce the needed of authentication. So for example, you need to provide your login password, you need to provide your MAC address, and ISE will validate and apply rules on that. So if it is, for example, a user, ISE will consult an AD on LDAP and check if this user is okay, if the account is not locked, if the account is still valid, and will reply back and allow and send to the authenticator, hey, you can allow this person to join in our network. And what protocols is used to authenticate? Basically, we have two protocols, right? Radius and TACAX Plus. There is I put it that here because there is some difference between them. So, and the difference is on the screen, right? So TACAX is TCP49, encrypts the whole package, right? So except for the standard TACAX header, but the whole package is encrypted. And TACAX, it separates the authentication from authorization, and that's why TACAX, it is more granular. I will show to you guys that later, but basically with TACAX, since they separate the authentication from the authorization, we can have more granular things to do, and that's why we use TACAX most of the time for the network access device, for the network access control for the users, right? So we control the we use TACAX Plus for the control of the device, to administrate the devices, and because it's more granular, we can authenticate the user and say what he can do, what the user can do, because of this the separation of the authentication and the authorization commands. Speaking about radios, use UDP 1812 and 1813. Old ports are 1645 and 1646. Encrypts only the password in the package. That doesn't make radios unsafely. And combines authentication and authorization. And radios is most used for authenticate the users. But it's also possible to use device admin administration, but it is not so granular as we can use TACAX, for example, because TACAX we can, as I said, we can segregate some authorization commands, and in radios is not so easy and it's not so granular as TACAX it is. So basically, radios to authenticate clients, users, to allow them to access the network, and TACAX to device administration. So here's some a draw for the authentication flow. So we can see here that this endpoint or supplicant is providing his credential. The network device or authenticator will get this information and will send it to ISE. ISE will validate, for example, if this is a LDAP or Active Directory, and if it is okay, ISE will reply back to the authenticator saying okay, it can access or not. We also have some kind of devices that doesn't speak 802.1x, and we should use MAB. So device that is not possible to use 802.1x, which is the whole protocol for the authentication, which contains a framework of protocols. So we can use MAB. What is MAB? MAC address bypass. So instead of use username, password or certificates, we can use the MAC address to authenticate the user or the endpoint that doesn't support a .1x. So, and speaking about the 802.1x, it's a framework of protocols, as I said. So we have like IP MD5, IP TLS, IP TTLS, PEEP, MES SHAP v2. I will not go through to all of these ones. Guys can detail one, but I will said about the ones that I already implemented. So I already implemented IP TLS, which use certificates. So client certificate authenticate plus a login and password. We can use in a lot of ways. I already use IP TTLS, but the TLS is not so safely because it allows a man-in-the-middle attack. I already use protected IP, which uses user and password, and we can decide if you want to check the certificate only on the server side. MES SHAP v2 already use it, only login and password, and we can also use the inner method for PEEP as MES SHAP v2, and PAPI I always use I think it was PAPI for some Merak devices, and we will go through it. So, but when we are gonna do some tests, we'll focus on the more secure, which is TLS, and this other here, which is PEEP, because it's awesome. We can also do great things with PEEP, and sometimes the device doesn't support a certificate client authentication, and we have to use PEEP, for example, or even MES SHAP v2. These will be the ones that we are gonna work. So the 802.1x architecture, it's same thing as before. So we have this supplicants here, and one thing that I want to mention, that how it's about the flow, right? So between the supplicants and the authenticators, only one protocol is allowed. It's the IP. So we are not seeing here any other protocol unless if you capture this traffic in the switch door or in the CCC interface, we will see only the IP requests, and that's it. Then the traffic, if the traffic, after the traffic being received in the switch, for example, it's being encapsulated in a radius package. So radius will be the EAP will be encapsulated here in a radius packet. So EAP will be here. Sorry for this bad type, and will be sent to the PSN. PSN will open the package, check everything in it, check the credentials, check if it is a IP TLS using client authentication certificate, if it is a IP PEEP using login and password, and checking only the server certificate. We'll check, for example, if it is authentication using LDAP or Microsoft infrastructure PKI, and we reply back to the authenticator, say okay, it can access, or even no, this guy is missing some information. And same thing here. Regarding the map, it's a simple thing. So the non-supplicant device will send the MAC address. The wireless controller or even the wired will encapsulate this in a radius packet sent to ISE. ISE will check, okay, this MAC address is allowed or not, reply back to the device and say if it is allowed or not. That's the basic flow for ISE. So we have supplicants, authenticators, authentication server, which is ISE, and the identity source, which could be internally. We can also have some internally identity source on ISE, like we can create each user on ISE database, which is not so granular. to do it. That's why most of the deployments use LDAP or Active Directory. So let's go to the next one. So here a little bit more about the features that we have on ISE. So we can enable guest services, very easy. I will try to show to you guys this, but I cannot replicate that because it's not possible to virtualize the access point yet. So guest services and secure, there is a lot of ways to do it. The guest, we can secure the network using the IBNS, yes, internet-based network access across wired. So we control everything on ISE. As I said, we have the supplicants, we have the authenticators, we have the ISE server, control everything. We have visibility of what kind of device, where they are located. With the feature of profiling, we can identify if it is an Apple, if it is a Windows device, Android, and these things. We can enforcing access based on asset visibility. So for example, if it is a MacBook or if it is an Apple device, I will give VLAN 10. If it is a Windows, I will give VLAN 12. If it is Android, I want to do a checkup first. So the compliance model, it's good, already implemented. So it's awesome. We can, for example, check. I think I already said that. Check the antivirus. Check if the patches are correct. If it has any specific software that you have in your company. The bring your own device is awesome. You can use to have the device onboarded, automatically use certificate, so we can register the device. We can put in that do not in that block list. In a block list if you want, after the device was missing or the device was stolen or lost. The device admin is TACAX. As I said, we can use TACAX to control the device admin. The PX Grid feature allow us to integrate. For example, we already did that. We integrate ISE with FMC to show to FMC a lot of information about the authentications and how we can provide more rules based on that information. Provided the segmentation without VLANs or IP-based policies. This uses the TrustSec technology. We can use TrustSec, for example, to create some rules. We can do this lab as well. I'll try to do a lab focus on this one. In this lab, we can have, for example, tags. That's for SGT, security group tags. And we can say that tag employee cannot speak with tag contractors, and we don't need a firewall for that. For example, this will be made on the layer 2 of the OSI model. I will show you guys that in more detail, but we can control without VLANs or IP based. We can control everything based on tags. And the threat containment, we can integrate, for example, with StealthWatch, and if StealthWatch sees that the devices have a bad behavior, we can go to ISE and simply quarantine this device. Basically, that's what we can do. So these are the features and use cases, and that's why I want to bring here. We'll go to most of all of them. Maybe for the Wi-Fi, I will need to create a physical lab and show to you guys, but I will try to do it. Let's go to the next one. And that's it, guys. So let's show to you guys a little bit about ISE. So we are using ISE in version 3.0, which is the recommended version right now. And this is the main dashboard of ISE. So we can see here authentications, how many networks device I have, how many endpoints is connected, a little bit about the system summary. You can see the CPU, the memory, how many authentications you are having. There is some alarms here as well. For example, my NTP is not syncing the last 32 minutes. There is insufficient virtual machine resource, but this is a lab, so these alarms will bring it up all the time. What else you have here? DNS resolution failure 7 days ago, but I think most of this is already okay. So in this new dashboard, it changes a lot comparing to the old version 2.4 or 2.7 or 2.x. So we click on these three lines here, and we have access, for example, to the operations, to the policy, to administrations. For example, let's see how is this deployment is. So we have only one ISE, and remember of the personas, this only node has admin, monitoring, policy serve, and PX grid, and it's primary for admin and primary for the monitoring, and also has the session profiler and device admin. So this node has all the services that ISE can provide, all. And for change that, for example, click here to check more details, and of course that administration, because it's only one node, we cannot turn off, but we can turn off monitoring, we can turn off the policy service. Here is where we enable the profiling service, which allows us to identify the devices, if it is Mac, Windows, and so on. To enable the threat-centric connect services here, and the device admin services here. To use passive identity service, I will try to speak about that later on this course. And the PX grid we enable here. So that's it. So guys, just to wrap up this session, we checked the ISE services, we checked a little bit about what we can do with ISE. There is a lot of things. ISE, it's a whole world, so it's pretty granular. We can do the same thing in many ways. So let's go back to our lab here, and to wrap up the session, and to show to you guys what we're gonna do next. So basically, next video we will start the configuration between S003, which will be our authenticator. The one of these two PCs, I will select, I think, user A, just to check, and to communicate with ISE01. But remember that there is a firewall between them, so we need to open the ports UDP 1812 and 1813, another port that is needed, because this guy S003 will be our authenticator. ISE will be, of course, our authentication server. We also need to communicate ISE, to integrate ISE and the Active Directory, to get the groups, to get the usernames, and to start to configure the supplicant, the authenticator, and the authentication server. So that's it for today, guys. Thank you so much for watching. Subscribe, comment, leave me a message, and that's it. God bless you. See you soon. Bye bye.